The session is now.
Good
Good
afternoon.
afternoon. Good afternoon, Namaste, and a very warm welcome to all our distinguished speakers, delegates, and participants joining us for session 6 of TTTD 2026, titled Open and Interoperable Systems for Seamless Connectivity of Heterogeneous Networks. My name is Akansha Arora. I work as a standard strategy executive at TSDSI, and I am the session coordinator for today's session. And it is my pleasure to welcome you all. Before we begin, I would like to share a few important hygiene announcements. These are also available in the chat window for your reference. All attendees except session speakers will be kept on mute throughout the session by default. Kindly post your questions in the Q&A tab of the conference tool. These will be taken up during the Q&A section. Questions in the chat box will not be entertained. If you want to enlarge the presentation, please click on the expanding arrow icon at the top right of the presentation screen. The tool is configured for HD video. You may switch to LD in case you are facing bandwidth problems. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can also use lounge facilities for networking. The lounge will remain open until the end of the conference. The conference sessions are being recorded and will be posted to the TTTT website in the next few days. Now, it is my pleasure to introduce the co-chairs and the conveners for this session. Mr. Abhijit Chaudhary is the founder and the CEO of Neural Networks, specializing in private 5G, edge computing, and AI-powered networking solutions. With over 2 decades of experience in telecommunications and data networking, he has expertise in product strategy, innovation, network architecture, and product management. Mr. Mahesh Naika is working as an assistant vice president at Reliance Jio, with over 28 years of experience in telecommunication industry. He has completed 2 terms as the chair of SGS's study group in TSTSI. Now, it's my pleasure to introduce the convener of the session. Shri A.K. Mittal has been serving as Director General of Telecommunication Standards Development Society of India, TSDSI, since April 2026. He joined TSDSI in 2017 as Advisor Networks, Systems and Technologies, where he strengthened study group network operations, enhanced member collaboration, and led TSDSI's engagement with ITUR and 3GPP. With this, I invite our co-chair, Mr. Mahesh Naika, to start with the opening remarks and take the session forward.
Thank you, Akansha. Good evening, everybody. I welcome you all for the session 6 of TTDD 2026. I think this is the last session of this series, but this is last session, but not the least. So I welcome you all again. So this particular session is on open and interoperable systems for seamless connectivity of heterogeneous networks. So basically, myself, and Abhijit Chaudhary from Neural Networks are the session co-chairs, and A.K. Mittal is the convener, and Akansha Arora is the session coordinator. So we have 4 keynote speakers lined up. I will explain about their profile as and when the session starts, and it's followed by a panelist moderated by Debashish Chakravarti. Basically, this particular session is about openness and interoperability across various telecommunication technologies, basically right from hardware and compute infrastructure to open AI, open RAN, cloud native architectures, open APIs, and open source platforms, which have become a crucial part of future technology development. Basically, open systems promote interoperability, vendor diversity, faster innovation, lower deployment cost through economies of scale, collaboration across industries, and provide operators with greater flexibility in building and evolving future communication networks. Basically, substantial progress has already been made. There are opportunities to make the systems truly open while addressing challenges like ensuring interoperability, security, standardization, and operational efficiency across multi vendor and multi technology ecosystems. Basically, next slide, please. Slide number 9. So, this particular slide is about the future of 6G, the India's vision. This is just a reminder slide, basically, which I have taken from our Minister of Communications, where recently our Sri Jyotiraditya Scindia ji says the future of 6G must be built on four pillars, that is interoperability, the common standards, innovation, and inclusive growth. If I take these pillars as just as an example, if you see, there was see one of the pillars of 60 talks about ubiquitous connectivity, which needs ubiquitous coverage. To provide ubiquitous coverage, basically we are going to integrate terrestrial network with non-terrestrial network, which includes satellites, apps based and drone based kind of thing, and also Wi-Fi is also going to play a key role in providing ubiquitous coverage. Due to which we will get ubiquitous connectivity, and hence we will get a seamless handover kind of thing where we can meet where we are going to meet the admitted quality of service or quality of experience. So first level of interoperability is across for supporting across different racks. There is another level of interoperability also exists. For example, within the same rack, if we have different portfolios of base stations, like for example, we have macro, micro, residential, rural, enterprises, industry, etc. So in all these cases, there should be a possibility of a migration, even when it is moved from one coverage, one suppose macro coverage to rural coverage and remote coverage, etc. There is third level of interoperability where multi-vendor. See, in case of homogeneous, we will have single vendor kind of deployments, whereas where the current scenario demands a majority on heterogeneous kind of networks, where we will have multi-vendor kind of solutions which gets deployed in the network. So in case of multi-vendor, there should be a interoperability possibility across different vendor products or solutions, which is key. If we see one of the issue, for example, in 4G, if we take the example of 4G LTE or 5G, SAN was one of the important aspect where we had vendor-specific solutions. When we deploy macro with macro SON solution and small cell with small cells SON solution, these two SON solutions were not coordinating, due to which the impact of SON was not up to the mark, meaning we wouldn't got the expected performance because of the SON, because every system was working in isolation. So there was no coordination possible. So due to which a new standard was supposed to be made, and due to which ORAN kind of SDO kind of organization came into picture to make the interfaces as open as possible, so that it will be vendor agnostic. The SON coordination will be vendor agnostic. So that was the intent of making the generation of ORAN, just to make the interoperability possible across different vendor solutions. Now, if we go to the second pillar, the common standards, basically these days, 60 everybody, the every industry or every academia is actually sailing on the 6G wave. So wherever, whichever SDO activities you are seeing, everybody is talking about 6G, whether it is ITU, whether it is 3GPP, ORAN, IEEE, etc., etc. But every SDO is making the standard from 60 point of view, definitely, but the perspectives will be different. But one of the vision of India vision is all these SDOs should coordinate each other and provide a unique kind of standard, a universal standard or the common standard from 60 point of view, so that if the approved quality of service or quality of experience shall be met whether the UE is under one technology coverage or when it is moving from one track to another rat or another system altogether. So to meet the admitted quality of service, I think the standard should be common across all the rats. That was the intent, but let's see how it goes, how our experts talk. Third one is innovation. Naturally, open. When we talk about openness, it is always about open hardware, open software, open compute, open AI, etc., etc. So a lot of innovation are already going on and also needs to be done so that more openness can be brought into the 60 purview. And finally, the inclusive growth pillar, where the services needs to reach the every citizen globally. But at the first step, let us target India first, and definitely across the global. Next slide. Next slide is talking about the pillars of the open system for 6G and beyond. If you see, there are five pillars. You can see one is disaggregation and virtualization. Basically, it focuses more on decoupling hardware and software. Basically, by separating the underlying hardware from the software layer, service providers can run network functions on commercial off-the-shelf cloud infrastructure. So the generic hardware or the open hardware can be utilized as much as possible. Then with respect to the open interfaces, as I mentioned earlier, the standardized interface, of course, 3GPP is coming up with standard interface. For example, XN or X2 interface is open. But still from the SAN implementation point of view, this particular openness across X2 or X10 is not sufficient. That's why ORAN is working on making this particular interface more open so that the SAN becomes the SAN can be worked across as vendor agnostic, where E2 interface is the one which they are trying to make standardized so that SAN can work more effectively. Then the second pillar is talking about AI native architecture and programmability, where they focus predominantly on RAN intelligent controller, that is a RIC, whether it is near real time or non real time kind of thing. And also AI as a service. Basically, intelligence is natively embedded throughout the edge and core, exposing data, computing power, and algorithm as a service. If we see the next pillar, that's talking about the integrated sensing and communication, where using AI and radio frequencies, 6G networks will not only transmit data but also acts as environmental sensors for movement tracking, hyper accurate localization, and environmental mapping, etc. Digital twin is again another open data pipelines where it will feed real-time network states into digital twins to allow for self-healing systems and predictive maintenance. And with respect to the fourth pillar, that is unified computing continuum, where it incorporates distributed computing and in-network computing, where workloads can be either dynamically orchestrated or it can be utilized where and wherever the demand is there, in whichever location or the node the demand is there. Last but not the least, the trust, security, and sustainability pillar, where it should be zero trust by design. I mean to say, built from the ground up, the system uses standardized security pipelines and quantum safe cryptography to defend against complex cyber threats. And also, if you see the green networks, were optimized via dynamic AI power management and energy aware network designs. Energy efficiency is a primary design target. With this, I would like to stop at this point because we have four keynote speakers where they are going to delve in deep on these aspects. Of course, with four keynote speakers, we cannot cover the entire areas of openness and interoperability. So, whatever is possible in 20-20 minutes of four keynote speech sessions, we will try to cover as much as possible. Now. Next slide, please. Now we will start with the first keynote speaker. That is the first keynote speech is on Open Gateway. I think Devashish Chakravarti He is the Senior Director, Advocacy and Industry Engagement at GSMA, where he leads industry engagement, policy advocacy, and ecosystem collaboration initiatives across India. Over to you, Debashis. The floor is yours.
Thanks, Mahesh. Let me. So I think, yeah, thanks. Mahesh, can you confirm if my screen is visible?
Yes, sir.
Not yet.
Is it visible?
Not yet, sir. Now we can see.
Sorry, can you see now?
Yes, now it's visible.
Is it visible?
Yes, sir, it's visible now.
Okay. Thanks, Mahesh. Thanks, Akansha. Thank you to TSDSI for giving this opportunity. So this session is about open and heterogeneous networks. I'm going to talk about the openness first, and then we will get to the heterogeneous networks. Um, I work for GSMA, which is the global industry body for the entire mobile ecosystem. We are headquartered in London. I'm based out of the Delhi office. I'm going to talk about the Open Gateway initiative of GSMA, which started a couple of years ago. And this initiative, in simple terms, is what it means is that it allows developers to use the network features like device location, identity, and other key network features. It allows the developers to use them to to make their applications available, and to simply bring all the operators at the same level. What this initiative tells is that enables is that it will bring all the operators on a single level, all the APIs at a very standardized level, so that any developer who is working and he wants to use a network feature doesn't have to integrate every time with every mobile operator in a country. Once the APIs are Camara compliant, they will bring them to a universal system for usage. So some of the topics which I'm going to talk about in this is the introduction to the Open Gateway initiative, some examples of the APIs, which are Open Gateway APIs, um, the channel partners who are involved to take this initiative forward, and briefly talk about some of the commercial case studies. So, as I was saying, this initiative is jointly being done with Camara, Linux, and the TM Forum. Um, as I was saying, that the intent here is to every operator has been working with a different set of APIs, and every time a developer has to work, they have to integrate separately with each and every mobile operator. So therefore, GSMA saw this as an opportunity to bring all the APIs at a standardized level. So what we're doing is that we are asking the operators to make these APIs Camara compliant. And once they are Camara compliant, all the APIs, the developer doesn't have to integrate every time with a mobile operator separately, and this also gives them the opportunity to expand faster. So if someone is launching a service or an app in let's suppose a startup is launching the service or an app in India, and then they want to expand rapidly to other APAC countries or anywhere outside APAC globally. So as long as those global mobile operators are also have enabled these APIs and made them Camara compliant, the startup founder can expand overnight their services to other geographies. So Here, what we are talking about is that the common framework is the open service, which is the northbound common network APIs. Even if there are few operators in a country who are not willing to expose their APIs to each other, this common framework, you can log into that, and that will be the northbound APIs will help them to connect uh, to the to the network features, and therefore enable them to connect to the cloud and the other applications. What we see is that North America and Europe will be driving a lot of the total use case value. Um, on the right side, we are seeing the verticals where these APIs are generally used. Media and entertainment seems to be one of the verticals which will consume and drive a lot of business from this. In India, we are these are still initial stages for the Open Gateway APIs to uh, take a formidable shape. But what we are seeing is that many of these use cases are essentially lying in the banking and financial sector. So let's look at some of the statistics here. As far as the commitment from the global operators are concerned, we are seeing that 88 operator groups have already signed up and working on Open Gateway APIs, and 73 channel partners globally are supporting this initiative. There are total, as on date, 75 APIs which are published in the Kamara, GitHub, and the impact of that is that some 325 commercial APIs have been launched. So when we say 88 operator groups, it actually covers more than 80% of the mobile connections which are represented globally, and more than 60% of these connections are protected by commercial anti-fraud APIs. This slide gives a sense of the channel partners which I was talking about, who have signed up and who are enabling the propagation of this initiative, Open Gateway. You can see a variety of organizations who have signed up for this: cloud service providers, the API aggregators, the system integrators. There are so many of these organizations who are working with us for taking this initiative forward and working hand in hand with the global mobile operators. Now, if we look at the entire ecosystem and how it is mapped, of course, the mobile operators are the ones who are exposing their network APIs, and they are the ones who enable the developers to and allow them to use their network features directly. Then there are
Hello.
network vendors, like Nokia, Ericsson, Huawei, who provide the platforms that expose these APIs across the operators. You saw there were the logos for all the hyperscalers over there who offer their cloud infrastructure and services via the APIs. the the CPaaS organization, communication platform as a service organization, they offer their cloud-based platforms through which again these tools are accessed. There are system integrators like HCL, Accenture, Capgemini, who are part of this initiative. And of course, then there are industry groups like the Kamara project, the Team Forum, and GSMA, while driving this at a central level. If we look at the supplier preference, and if we try to see the developer attitudes, how it has grown over the last couple of years, we see that hyperscalers are very popular in this graph that you're seeing. um, this is a comparison. The black and white is between 2024 and 2025. How developers currently work on the network APIs with telecom operators, with the network infrastructure vendors, cloud service providers, with enterprise application providers, and with the CPaaS providers. There is a online tool which is available globally for every operator in the world to upload the APIs the moment they become Kamara compliant. This provides a one-stop shop for anyone to log in and see uh, which country and which operator is offering which API, which has become Kamara compliant. Makes it easier for the industry to have a sneak preview of the the APIs that are available and which MNO has that Kamara compliant API, which will enable them to start releasing their services. This slide will talk about how globally the impact of the Open Gateway initiative has had on few critical initiatives like the anti-fraud APIs and the communications quality APIs. What you see in blue is that two-thirds of all global connections are protected by commercial anti-fraud APIs. We'll talk more about them, in the coming slides. That which are these APIs which are used for dealing with frauds and scams, because fraud and scam is something which has grown rampantly over the last uh, couple of years, and we don't see that you know with the advent of AI, this is only going to increase. GSMA has also started a APAC wide initiative called ACAST, which is focused on dealing with frauds and scams. This is a menace which we are dealing, and the more digital our economy gets, the more we are susceptible to falling into these frauds and scams. So the some of the APIs which I'm going to talk about later will help us secure the mobile connections. Um, so yeah, so let's look at some of the examples of the APIs. Number verification, number verify, as we call it, comes as very handy. So it simply verifies the phone number associated with the device owner. Uh, what it can do, it is there to provide with security and fraud prevention. It offers seamless customer experience, whether through an OTP or silent number verification. It is these are the use case is that services that require customers to be verified prior to allowing access to sign up for any service or onboarding them for any service, whether it's a login authentication, a password resetting, or any kind of ticketing event. The second one, which is clearly linked to the frauds and scams, is the SIM swap. Earlier, you will not get to know if your SIM is being swapped by a fraudster. So this API performs real-time checks on the activation date of a SIM card, and therefore it prevents the fraudulent activities, and it checks if customer has recently performed a SIM swap. It keeps a digital log of that, and banks can also integrate this with APIs with fraud system to trigger alert based on the risk threshold. So many of the Indian banks are already using the SIM swap API, which helps to secure the interest of their customers. And this definitely acts as a additional layer on top of the existing verification methods, which we already spoke about, the number verify. Device status, again, used for reducing fraud, and it gives you real-time push notifications. Checks whether the customer is roaming or not, verifies whether the customer roaming status, and basically receives timely updates when the device has changed location. So this is very important when a customer is actually roaming, but someone the bank detects that there is a login attempt on his account from a home country. So the integration with the mobile networks is essential, and this again proves that the telecom networks are an essential layer for the digital infrastructure that we have created, and that digital infrastructure is only getting more interconnected, more intertwined, more complex, with every passing year. So telecom will have to secure the networks and ensure that the integration with other sectors like banking is crucial to ensure that we are the customer end customers remain safe. Device location is another API, and that is the one of the interesting use cases here is that let's assume that I go out there to take out some cash from the ATM. The mobile device has become so integral to to our lives these days that chances are very less that the person is who is taking out money from the ATM is not carrying his mobile. And so if there is a large sum of cash which is getting withdrawn repeatedly, this is another way of finding out whether the mobile location is far away from the ATM where the money is getting taken out. So it broadcasts also travel related services to enhance the customer experience. Sorry. eKYC, again, as the name suggests, for it's a KYC app, secure and automated way to validate identities, and ensures accurate and efficient customer identification. This API is used very frequently again by many banking and financial institutions for identity verification. Yeah, bank and fintech companies, they trigger eKYC API to verify new customers, comparing customer supplied information against whatever record has been supplied by their telecom operators. Quality on demand is an advanced API, and we don't see much of the use in India because of net neutrality. But it's a very useful API which is used in other countries where if you want to enhance the experience of one particular service, this API helps in doing that. This is a heat map which will talk about the relevance of the APIs mapped against every vertical industry. So I'm not going to go through all of this. Just pick a couple of them. Like
Last 2 minutes, please.
yeah, thanks, Mahesh. So like if you look at financial services, which is the fourth column, you'll see that the heat map really heats up in KYC, which I spoke about, OTPs, number verification, and device location, right? Similarly, if you look at the last column of healthcare, again, KYC, number verification, OTPs, these are, very important. Um, I will move on, quickly talk about some of the commercial case studies. Before I, go to the case studies, I just want to say that, there is, again, a library which is available, on the GSMA website, which can give you access to all the use cases which are available globally. Um, I will just talk about a couple of them, and since I've already been reminded of the time, maybe I'll skip these slides. So this is an example from Sri Lanka on Lanka Pay, and the only thing which I want to talk about here is that the success of this initiative from GSMA, the Open Gateway Initiative, is guaranteed only when all the operators in the country come together, join hands, expose APIs to each other, and work. This particular example that we're seeing here, Lanka Pay, Dialog, Hutch, they all came together to, work on this international scam operations to deal with this using the common API for this e-commerce solution. We have several other examples which I can keep on talking about, but I'll skip. All these examples and case studies, the commercial case studies, are available in the GSMA website. Cambodia, well, that's a hotbed for most of the scams that are happening. I will stop now and hand over back to Mahesh.
Mm, Thank you, Debashis, for a very insightful session. Basically, within 15-20 minutes, you have enlightened us about unlocking the API economy through Open Gateway. And also, you have mentioned that around 75 APIs are already published. Looks like this particular solution is already in the mature stage. Definitely, it helps the application developers to integrate with any of the operator network and provide support for optimizing the performance of the network and also enhance the business. Thank you very much. I think there are no questions for you. If any questions are there, probably we can take up during the panel discussion. Thank you very much.
Sure. Thanks, Mahesh.
Next, we will move on to the next keynote session, that is about architecture requirements and Vodafone's view on 6G. Chandra Chellagonda is the CEO of the Fiverr Foundation, a global non-profit advancing open source technologies for smart cities, data spaces, and digital public infrastructure. With over 26 years of leadership experience in digital transformation, he has been instrumental in building open, interoperable ecosystems that support governments, industries, and communities worldwide. Over to you, Mr. Chandra. Floor is yours. Chandra, if you are speaking, I think you are on mute. Mute. Akansha, is Chandra online?
Yes, sir, he is there.
Mr. Chandra, over to you. The floor is yours. Akansha, if Chandra is having any issues, shall we move on to the next keynote speaker? I think he is sending some message. I'm speaking. Chandra, we are not able to hear you. I think you are on mute. I think Chandra is trying to rejoin the connection. Akansha ma'am, shall we move on to the next keynote speaker till he rejoins?
Can you hear me now?
Yeah, yes, Chandra, please go ahead. Floor is yours.
Yeah. All right. Thanks, Mahesh. I don't know what happened. I just need to refresh the browser and everything started working. And thanks for giving me an opportunity for this. And I think, Mahesh, the title of the presentation you mentioned might be wrong. It is about the open systems, not about the network. But Akanksha, can you please load my presentation here so that I can run through that?
Sir, I'm sharing the screen. Can you, is it visible?
Um, at least not for me, but for others.
No, it's not visible.
No, we don't see it.
Maybe I can share from my screen. So if that's so, it needs a PDF file. Okay. Right. Okay. Thank you. So at least, yeah, I'm able to see it. I hope others can see it. So my name is Chandra. So I'm going to talk about the importance of the context in the data in the 6G era when it comes to the smart ecosystems. I'm sorry for the initial hiccup we had. When we tested this one, it kind of worked, but I don't know what happened. So I'm Chandra. I'm part of the 5-year ecosystem for more than 12 years now, as a community member, as a board member, as an architect, and finally as a CEO. And I'm also having another hat, which I'm actually heading a data as a data protection officer, group data protection officer for a Swiss company called AdFinis, which is also aligned with the open principles and the open source activities. Then we can go to the next page. So the AI era, I think the AI and the 6G era needs a context. So it's not just the connectivity what we need, and I think the connectivity is one of the definitely enabler, and it actually brings a lot of revolution connecting the sensors seamlessly. But the important thing is to get the context. So connectivity is an highway. So we all definitely need a hard infrastructure. It is like good highways and everything, but the context is a GPS, which needs a direction and which needs some. So where do we navigate on this? So for us, the raw data is the noise. As you know, a particular sensor which is connected to the internet reads 32. This doesn't give anything, right? So we don't know what 32 is. The context is an intelligence to it. That is 32 degrees at the road node X, near a school, during the peak traffic at that particular time. So then this data makes sense for us, right? So when we actually say 32, we don't know what it is. So could be anything. But now an AI agent can take this as a meaningful, safe action. That means if you feed to an AI models and a 32 number, it could actually give a very crazy results on that. It could say a lot of things. But 6G, when 6G is connecting everything, and then the sensors are connected, this context is pulled into it. But without a common context model, every vertical speaks their own different language. Context poor networks is a waste of full 6G's potential. So that's where we actually that's where the context actually makes sense. And every data, every report, every publishing scientific journals are saying that the 6G will generate the world's largest data sets. The question is not the speed, how it, because 6G is solving the speed issue. 6G is solving also the intensity issue, all the density issue and all. But it's what is this data meaning for? So next, please. Yeah. So I just put a little bit of a Star Wars theme here on this. So world is a digital twin. So we are getting more and more digitized. Well, a lot of data is digitalized, and I think during the introduction of this session, we spoke about the digital twins. And there are actually, imagine we ourselves are a digital twin. So I have a data of my health, my financials, my credit rating, my job, my CV, everything. So I'm also a digital twin. I can be represented as a digital twin. When I'm talking about not a 3D digital twin, more on the data point of view. So let's actually go to a bit of a dark side on it. So a vendor locked or a closed platform, which is basically a vendor locked. So you are a data for them. So there is nothing about it. So, and your data is valuable. And opaque governance, there are a lot of organizations which actually promise an open system, not same as open source, by the way, an open system, but it's still an opaque governance. Still, they can control it. And we have seen in many instances where the board or a share market drives their decision making in a different country. It's not even in the country which we are. So, and a full sovereignty risk, the geopolitical, and there is something called the Cloud Acts and all these things, which forces them to share all the data inside to a different area, which is totally no go for a lot of people. Then the perpetual cost. So when our systems are going to be more and more depending on it, our lives are going to be more and more depending on it. as a digital twin, we are going to be more and more depending on it. They can unilaterally decide what type of costs they are going to impose on us. And this is something that which is there we have seen many instances in the past about this one. The open way is actually, I'm not saying okay. So we can you please go back to the slides? Sorry. The open way is that we have a 5-variant NGSILD which has been there for 15 years now. It's an open standard. It's an HC standard. It's openly available for free. It's quite elaborated. Many use cases can be done. A community governed, more than 300 members, EU, and a non-profit charitable organization, which is managed by the community. But a community still owns the technical roadmap. They decide which direction on the technology goes. The foundation is just to enable that the community is working. And the full data sovereignty. So take this stack as it is, use it. And every 6 months, this stack is updated. It's been going on since 2011. The consistency can be seen. And the full code is, we ensure that whatever is available in this stack, a deployable stack, is 100% royalty free, open source, and no hooks attached. And it's vendor neutral. So a lot of big companies, the telecom companies in Europe, Japan, South America, they even started in Africa, India, has been contributing to this, and there is very vendor neutral on it. It doesn't mean that actually there are proprietary solutions based on this solution, but what is the solution which is, or what is the stack which is available is fully vendor neutral and open source. Thank you. The next slide. So the NGSILD is the common language, is open context language, which has been spoken. So it's inspired by JSON-LD. So it's been used in smart cities, smart health. Smart cities is predominantly used all over the world. Smart energy, smart agriculture, manufacturing, and smart mobility. NGSLD is simple yet powerful REST API. It's a linked data, geoquery subscriptions. It's a subscribable API at the same time. A federation, temporal operations. More than 1,000 actually, or 900 open smart data models are also available. Because when we are talking between the systems, it doesn't mean there is a common protocol or a common API standard, but it needs to also understand the data model which is there. So the data models are maintained 24/7, where a data model can be referenced when the data is being sent. So automatically, this is useful for many automatic systems. Here it is a very simple application. So enterprise data, third-party APIs, application, AI services, digital twins. The data is coming from the top. So I just reverse this architecture. Generally, the data is going from the down from the sources. So in the 6G era, all the IoT devices, smart systems, and the context broker puts them together, creates a single API and gives the context to all of this data. Then this data can be used by third-party APIs and also applications, AI services, and digital twins on applications. We have been open source and foundation in EU back in 2009, and it's been around for 15 years. The foundation itself is established like 11 years ago, but 10 years ago, sorry, but the community has been around for more than 15 years. Next, please. Can we go to the next slide? Yeah. So proven at scale, also in India. So it's not a very a strange word for India. 5-way technologies, more than thousands of deployments around the world. The beauty of open source is we don't know how much it is used. So we don't have any restrictions on who is using, or anyone has to come and back tell us that what they're using. If they have a problems, they're actually posting, they're contacting. The community is in Discord, which is quite huge. So on the global endorsement side, India is already leading. So we have a standard in TSDSI itself in 2024 about the cloud interoperability standards, the Bureau of Indian Standards, which has been there in the standard since 2021. IUDX, which is an Indian Urban Data Exchange, the Trusted Data Exchange platform is using NGSILD API for smart cities, collecting the data from different, I think more than 60 smart cities, and also integrating the data from agriculture. So they have an agriculture data exchange also. So on HC, it's a standard which has been managed at HC. GSMA, we have an IoT reference architecture recommendation as an NGSILD. With TM Forum, we have been doing a lot of collaboration with them on the marketplace, specifically to the APIs. How do we get it to a wider communities, and also how do we sell the data? So how the data economy could work. European Union's Connect Europe facility has very few blocks, 5 blocks recommended for the connect digitally connecting Europe across Europe. So context broker is one of it. Japan, Spain, Brazil, Slovenia. I think the organizations cannot even apply for a tender if they are not having NGSILD and they're not certified by the Fiverr as their platform. So it's actually growing. It's not only these countries, but we have Fiverr has been used in more than 35 countries, and it's spreading quite much in Africa right now. And I think it was in India. It's been there since 2019 already. Next slide, please. And just to add one note here is that IUDX is one of the highest data models contribution, because when India goes on these kind of things, India goes on with the scale. So we have 70% of the data models contributed by IUDX, and we have a criteria that all the data models which are listed should have a live use case. So any live use case which is not having a live use case is not allowed in the data models. So let me go to the, I want to bring into the context MCP, also an open protocol for the AI agents, and how we basically can connect it and what we have been doing in this area. An MCP is an AI agent with, HTTP is to a web browser. So how HTTP standardized the web browsing? So it's an MCP. We are hoping that it would be, communicating between the AI agents, which is a universal protocol. So I'm just putting the names here. People can use sovereign AIs also, but it's a Claude, GPT, Gemini's. Then it basically goes to any database, fetches that, and then it can communicate with that. So what we did is that we have added an MCP server, MCP, an extension to an context broker, NGSI context broker for the reference architecture. There are 6 context brokers, certified context brokers by different vendors in the market. Everyone is implementing partial specification of NGSILD. That is also in a way a context broker, but we did not get them certified because they have to use use the specification, or at least justify that why they're not using it. So there are many versions of implementations of it. The AI agents can directly query the live digital twin. So because it's a subscribable API, it's an event-based API, the NGSILD. So there is a live and real-time data which is available outside there, but from the context broker, and this can be queried directly through the MCP, and then data can be given. So this has been an extension added already and published. It is available for everyone to use. So an MCP
Last 2
plus,
minutes, please.
yeah, MCP plus NGSILD is a fully open vendor neutral stack for a physical world for an AI reasoning. We can go to the next one. I'll just put the cycle here: physical world, NGSILD context broker, MCP server, then AI agent, and then the smart decisions. And I think this would be there, and this 6G will accelerate this because of the data rates and all. Same query semantics, answers, any AI agents, no proprietary middleware, and full open source. Next page. So I just would be saying this one thing, that may the open source be with you. Adopt NGSILD, build on NGSILD plus MCP, join our Fiverr Foundation and support us. Next slide. Okay, so I think the latest version is not there, but I think the main thing is that we are organizing a Fiverr Global Summit every year. So this time it will be in France, Menton city, beautiful Riviera. So the city itself is using Fiverr's stack. So we are all welcome, and please, on my background, you can see actually the dates on that. Thank you very much.
Thanks, Chandra, for a very insightful session on context data fabric for 6G smart ecosystem. In very short duration, you have just highlighted about AI era needs context, not just connectivity like that. Something like raw data is noisy, context is intelligence, etc. And also, you mentioned that 60 generates the world's largest data set. But I think to start with, for 60, we may end up using 5G or 5G advanced data set. And also, you have covered something like a vendor locked platforms or closed platforms and open context platforms, which is very insightful. And also, you mentioned that 70% of the data models are contributed by IUDX India. So, which is again a great point from India perspective. Thank you very much. Uh, Thank you very much, Chandra, for your insightful session. Next, we will move on to the next keynote speaker. That is the title is Open and Interoperable Agentic Networks, Standardizing Intelligence Across Radio Transport Core and LTN. Ashish Bose is a distinguished member of technical staff at Nokia with more than 2 decades of experience in Nokia Plan and Core CTO office. He focuses on agentic AI for autonomous 5G and network. Over to you, Ashish Bose. The floor is yours.
Thank you, Mahesh. Let me share my screen. Let me know when you guys are able to see my screen.
Yes, it's visible, sir.
Thank you. Okay, so to set the context right, let's talk about 5 different vendors. Right? Huawei started speaking about the complete agentic core in NWC Barcelona, where they were actually talking about uh, breaking the DNN based network, the core networks, and moving towards a service based, an agentic service based core itself. The entity Docomo deployed the complete agentic core on AWS Bedrock. Bharti Airtel have a lot of agentic ops applications in production. Um, NVIDIA conducted a recent survey, which was in 2026, where they have actually presented the usage of agentic protocols and even agentic systems have been up from 49% to almost 66% in telecom. Amdocs have already proposed an agentic OS. Like I know neural networks are also an agentic OS promoting firm, but Amdocs has also promoted something in the area of agentic OS, and this is just to set the context. So everywhere in telecom, the agentic systems are really coming into a prominence, and obviously they are not here to actually get adopted into telecom. They are here to revolutionize. So we from telecom just should not be building the pipes. We should be adopting them, and we should be moving ahead into monetizing all these things. Now, if you look at the old pace of how the evolutions were, decades, 2G to 3G, 3G to 4G, 4G to 5G, almost every decade has seen a generation, right? And then after the 4G or towards the end of 5G, the Open RAN evolution came into place. The SMOs, the non-real-time rigs, the near real-time rigs, all those things really came into picture. And then exposing the R1 interface outside, so that people could really come and prepare their R apps on top of it, exposing the interfaces by which people can create X apps on top of it. So kind of open interfaces wherein see the underlying network is basically exposing the APIs, and the application vendors or the operator itself, they can actually create the applications on top of it. But this took years and years to really come into the action, right? Now, look at the new pace. In last December, the MCP was donated by Anthropic to Linux Foundation. And in February 2026, the NIST, the security department of US, like they started the Agent Standards Initiative so that like they can have a much secure future. They know that like also, things are moving in that pace. Like we need to have a proper standardization, a proper gating in order to have a proper interoperability and like a proper usage so that like people don't misinterpret and misuse all these things. So the speed of standardization, like this slide, I just wanted to say that like this the speed of standardization needs to really pick up on the agentic ops ways of doing it, not just the MCPs and A2As or ACPs and things like that, like but the tool use or the agent to agent communication. No, like we need to interface the proper thing into the network, and I'll be speaking about that in the coming slides. So look at ORAN, like they and the like what our GSMA friend has told about the open APIs. They all expose the Kamaras, the ORAN, like the R1 interfaces. Everybody exposed APIs. But now, using those APIs or within the system itself, like there can be two things. Like one is like the application level agents, and one is the system level or the network function level or the DU level agents, right? Like so, everybody can create a vendor stack. Now, we actually broke the vendor lock-in using the open APIs. Now we have another problem to solve. On top of that, like there are vendor lock-in, there is a complete agentic stack. If everybody brings their own agentic stack, like a complete agent ops system, just imagine Legacy, everybody will be having duplicate exposure layers for the AI agents. For example, somebody can actually create a policy around Rego, and somebody can have a group-based policy for the agents. Like, okay, if this agent is supposed to use only these tools for this particular thing, and somebody actually passes a Rego-based policy against that, or somebody creating a group-based policy. Okay, these users are able to use these something like our LDAP kind of a structure. So those things, like everybody comes with their own things, their own infrastructure around that, like their own framework around that. Obviously the hell what we were trying to actually cross over with the open APIs and open RAN is not going to suffice over there. It's not going to be sufficient over there, right? Like so it needs more. It needs more. The vendor, in order to avoid the vendor locking, because everybody wants to actually go first, right? Like so now is the time to actually standardize a lot of things around these things, the agent ops and all those areas. Now, coming to the automation or the autonomy part of things, long back, the level 1, level 2 autonomy as defined by TM Forum was rule based. So if at all I have these KPIs calculated, do this specific action. If nothing, and why it has reached there, nobody knew. And like what should be the see, if I perform this particular action, if there is an anomaly case, until a rule is there, nobody is going to do that, right? That is what the level 1, level 2 used to do that, right? Like the rule based automation. Then came the AIOps. Somebody, I mean, like the classical AI/ML and all those things really came into picture, right? Like so you had the leverage of the classifications, the predictions, the regressions, all those things. They can detect anomaly detection. All those things really came into picture. The prediction. So because you have a lot of time series data out there, like you can predict over a time. Like so, what will happen? For example, in India, in Kumbh Mela, like obviously, in the next Kumbh Mela, a predicted amount of subscribers that will be in that particular place. So those kind of, and we could really take an action around that, but no reasoning why or how this needs to be how this needs to be done, right? Now came the agentic reasoning part. Like, so the level 4 plus, or the level 5, we're reaching towards level 5, the complete autonomous systems. It can do causal analysis. It can do closed loop learning. So it, once it learns that, like, okay, see, once initially you can have the human in the loops to make the system learn. Okay, once the system identifies, yeah, this is some particular thing that this is some particular action that I could take based out of this particular inference, and this is the reason for that. And the user, or the the corresponding engineer comes in and he validates the results, and he gives a go green for that, and then the system can learn of these things, right? Like, so the next time when a similar when the same situation comes, you do not need the user to come and validate. So self-enabling, a self-enhancing system, that really is going to be the future of the autonomy part of things, the intelligent part of things, the intelligent autonomy, right? Now, what is the main difference, or like, see, what is the handover between the AI ops to the agentic ops? So you need to have a trigger, and what I would say about this particular trigger is basically an intent. Okay, what this is what we need to standardize. What that most of these intents, what is a goal I need to achieve? I need to have a coffee, and how that coffee is prepared, whether it is prepared by Starbucks, or whether it is prepared by Tim Hortons, or whether it is prepared by McDonald's, or whether it is prepared by my coffee machine, it doesn't really matter to me. I just need a coffee. And then, like, I can add specificities to it. I can add two creams, two sugars, or one milk, one sugar. I can add more specificities to it. So this is what the intent needs to be, and it can be human written, human NLP, or the natural language way of telling it. So this intent is something, or these kind of intents is something that should be standardized. So what should be the goal? What should be the specificities around that particular goal is something that should be standardized. And how it needs to be done, let the vendors pick up the task of doing it. The intent, it actually is the crossover between, okay, I have predicted this particular result. Now what needs to be done? You hand it over. So that the and I my goal is to have the system running continuously, and this is what the KPI that I predict for this particular period of time. What should I be doing? And then, like, obviously, the agentic ops system really needs to chime in, and it needs to be picking up. It needs to reason about that. It needs to understand it, and it needs to make a corresponding action if required. Right? Um, so uh, here, when I talk about the remediation thing, like that, that is where, like, obviously, um, we were actually seeing about the MCPs, right? Like, so the tool call mechanism. So how the agents could really make that corresponding tool calls, and these tool calls could basically. So we actually talked about Kamara, like when we talked about GSMA, right? So now look at, if you have a Kamara based system, you can also, so most of uh, the softwares, like, for example, if it is a Kongs, or if it is a Rapid API from Nokia, or if it is something from Google, all of these vendors who actually create this framework or this platform, they actually expose the API, the MCPs also. So any agentic system, you can have a complete authentication authorization loop over there, and what could be consumed by these agents, you can actually expose to them, and then they can decide what tool to call when. And then, like, obviously, the agentic ops really circles back the loop, right? Like, so it performs an action, then you're actually then the observe part of things really comes into picture, and really observes the system again. Now, this is exactly what I was talking about. Like, so this is the old World War II concept, which we can call the Boyd effect, right? Like, so General Boyd said, like, okay, the kamikazes are ramming the US aircraft. Now, every time, like, before they fire, they should be calling up the base. So how to make a very fast, quick decision? You should observe, you should calculate, the pros and cons of it in a very quick time. You should make a decision and then act on it, and then you should continue this particular. This is the basis of the autonomy in the modern era. So any agentic AI systems, they have the sense, think, and act. And then again, sense comes into picture. So that's exactly the observe, orient, decide, act principle. Now, this particular
Last two
thing.
minutes,
So
please.
yeah, sure. The observe part, it actually observes the corresponding KPIs, it calculates, then it reflects on it, then it purposes it, it validates it, and then it continues this particular loop. Now, this is something like a tired hierarchy that I really want to bring into picture for the radio transport core and NTN. You can have a hierarchy of this particular agentic loops, right? Like so, it can have uh, at a higher level of hierarchy. For example, at a slice, like I need this particular slice, and what that slice needs to be at a RAN slice controller, at a transport slice controller, or at a core slice controller, a lower order hierarchy can be done. And then like the use cases on top of it, the kind of KPIs that you want to monitor and the kind of actions that can really become the use cases on top of it. Now, the one of the standardization things that what we really need to do is to as I had told before, we need to standardize the framework, the underlying things about the agentic identity, the open protocols, the data governance, all those things needs to be standardized. And anything like whoever creates the agents, whoever create the operator agents, anything could really become vendor specific. Like or anybody could really create it, like anything underneath all the frameworks all the interfaces that needs to be standardized. Now one very small thing before I clearly go ahead and wind up. The you see one of the monetization aspects I really want to portray over there, a UE agent talking to another UE agent. And this can, if this can be done via the telco networks, and the SIM being a very strong identity thing, we can have, instead of the Suki Supi, we can have, and the each agent instance can have its own ID, right? Like so, the agent can have an AGPI and an AGCI, which really can be authorized by the core, and this can be a modern monetization aspect. And why this can be a modern monetization aspect is just because like it can really rework the fincorp, or the fintech area and any other area where the corresponding transaction should be between an agent in your phone and an agent in the network or an agent in another phone, right? And which is authorized by the core network. And before I wind up, I just wanted to talk about just give a view about the reliable autonomy. It should be a progressive path. It should be defense in-depth security. It should have it should be adding upon things, and it should be full auditability. And yeah, so before so all the agentic interfaces, it should be done on 3GPP standards, the TM4 autonomy. We should be doing the autonomy level standardization going forward, where we should also actually think about the post quantum era of security and things like that in all these different aspects. And even in the 3GPP, we should also think about ISAC and like how to actually validate the QoS parts of things. So, and the cross domain, like they should have the shared KP benchmarking and the quantum zip signing for that. And that's it from my end. Like I had to rush it through towards the end, but thank you. Thanks for this opportunity to speak up.
Thank you very much, Ashish Bose, for the insightful session. Yeah, you have rightly mentioned that every domain, anything and everything, they are trying to deploy agentic AI. You can rename it as agentic AI native, also probably, if I'm correct. And also, you have covered every part of the network of independently getting agentic capabilities, which is exactly why interoperability needs to be fixed. And hello. Am I audible?
Yeah, yeah.
Yeah.
Yeah,
Uh,
perfect.
thank you very much, Ashish Bose, for your insightful session. Basically, you have tried to cover that every domain is basically racing towards deploying agentic AI. And also, you have covered ORAN APIs, solve the interoperability fight at the interface layer. But the closed agentic stacks moved the same interoperability fight to the intelligence layer. And also, you have covered slightly about the gaps related to the rule-based automation, AI ops to agentic reasoning. And also, you mentioned the needs to standardize about the open and off related aspects using cognitive layers. And also, the agentic AI framework needs to be standardized at 3GPP and covered some of the aspects related to the UE agent brokered by the core. Thank you very much for covering all these aspects within 20 minutes. Thank you very much. We will move on to the next keynote speaker. So the next keynote title is AI RAN Innovations with Open Source Software. Charles Santosham is a senior R&D management professional with over 25 years of experience in wireless communications, spanning system architecture, system engineering, and layer 1 to 3 technologies. He holds a master degree in engineering from the Indian Institute of Science and an MBA in international business. Over to you, Charles. The floor is yours.
Thanks, Mahesh. Can you hear me?
Yes, sir. Loud and clear. Please proceed.
Okay, let me present my screen. Do you see the slides?
Yes, sir, it's visible.
Okay, thanks. Thanks, Mahesh, for inviting me for this talk. So I'm Charles Santosham. I'm part of the NVIDIA, working out of the Bangalore office. I'm taking care of the AI/RAN initiatives within NVIDIA, especially on the layer 1 and layer 2. So here I'm going to talk about the AI/RAN, the innovations, and what does openness mean? Openness, is it just about interfaces, or is it much more than that? So to me, the openness is not just interfaces. So we will look at it in detail in terms of what is our perspective with respect to openness. RAN, as we know today, mainly focuses on interfaces and interoperability. So the interoperability is limited to the interface that we are talking about. For example, F1, E1 interface, or N1 interface, and so on. But so much of money has been spent in standardizing all these interfaces. But still, we don't see predominantly a lot of deployments which can use different vendors over the F1 interface or the E1 interface kind of things. Of course, between RAN and core, you see a lot of interworking, but it is not percolated to lower levels. And on top of this, we are trying to bring in innovations like AI, rigs, and Gen AI, LLM, and all those kind of innovations plugging into the RAN systems. So it makes a lot more complex and difficult proposition to make them integrated into the system and produce value. So the whole dream of a multi-vendor plug-and-play system is good, but it is not good enough for the speed of innovation that we need in 6G and the kind of improvements that we need to achieve the throughput demands that are arising from the latest applications as AI is percolating into every sphere of life. So from our perspective, the openness is in different levels, right? So openness is not just about interface centric. It's not just about plug and play. It's also about how open is the innermost layers and the software that allows others to modify and develop on top of it, right? So the primary requirements for complete openness is captured in 5 different levels. The first level is the first and foremost level is basically the open sourced code base. The code base should be open so that anybody can pick up the existing open source software and build on top of it rather than developing everything right from the scratch. So as we move towards the AI-based systems, it's not just about the source code, it's also about how do we collect the data from the networks, existing networks for various KPIs, various traces, logs, and data that you need to pull out from the networks and the network elements, and how do we make use of them, right? So the number 3 level is basically the open models that make use of the data that you're collecting from different network elements, and how do we make these models to be open and open for innovation, open for modifications by different vendors. The next 2 levels are more in terms of how do you develop the software for the network, right? So the open scientist is more about how do you develop algorithms, innovate algorithms for improving spectral efficiency or quality of service and other requirements. And on top of it is the open developer, which is basically the concept where you are speeding up the pace of the development using agentic AI tools. So the whole stack, as you can see from 1 to 5, is about the openness is about evolve and create rather than just plug and play. So it should be any open system should allow anybody to come in and modify and bring in their own innovation, quickly prototype and be able to bring it to the system. So that's what we refer to as open innovation framework, rather than simply limiting ourselves to just the interfaces and plug and play aspects. So in order to rethink openness, first thing is ecosystems have to be designed around co-evolution and creation, and not just plug and play. Interoperability, move beyond interfaces. The framework must evolve basic connectivity and standardized interfaces. Prioritize innovation over compatibility. It's not just about compatibility between different vendors' equipment. You just plug them in and they start working, but without knowing what are the black boxes within each of these systems and how they behave and how they work across the system. And rethinking openness. So true openness enables systems to evolve, adapt, and co-develop, not just integrate between different vendors. The future state of the whole innovation framework that we are looking at is more from platforms built around open code, open data frameworks, open models, and open research and developer frameworks in a collaborative ecosystem that accelerates continuous innovation. And which helps us to increase the pace at which we can develop, create, and deploy the systems over the network. So the first pillar of the overall open innovation framework, as we refer to, is the open source telco code base. Where are we today? So today, the OAI started sometime a long time back in terms of the research community. It was meant for research community origin. And so until that time, it was all interface-centric openness. We had a lot of black boxes just connected over standardized interfaces without much insights into what is happening in each of those black boxes. And to evolve that to the code-based level openness, so the OAA started this for the research, and then the packet codes became already open source now. And Okudu, or the Open CUDU initiative, supported by FutureG, NVIDIA, and other 17 different other companies, was introduced in Mobile World Congress 2026. And that was a big milestone where the RAN is also moving towards the open source software apart from the core. The RAN gap is getting closed in terms of what an open source software can achieve within RAN as well as the entire network. So the objective of the Okudu is also to create a commercial grade open telecom stack, and be enable the openness so that people can build on top of it and quickly bring the solutions and innovations to the deployment with much lower effort. The second pillar of the overall solution is the data lake. So data lake is about how do you collect the data from the existing network elements, and how do you standardize the interfaces towards collecting the databases. So the telecom sits on a uniquely rich data. Right from IQ samples, telemetry, KPIs, traffic, levels of traffic, the geospatial information. But all these are locked in silos because of the black box approach today. So opening structured network data to a global community was the main objective, and that's when we introduced the open data lake kind of a solution, which can sit right next to the DU, collect information from the network element, right from IQ or the FAPI interface or any of the interfaces that you want. You can expose it to the open data lake, and the data lake can either store it or stream it to an agent, which can run in parallel to the DU in the same server for you to make intelligence out of the data that you're collecting continuously. So the richness of the information is amplified because with this real-time and shared memory-based kind of a interface between the DU and the data lake or the data applications, is that you can collect a huge amount of data, even at the IQ level, whether it is channel estimation at the every slot, every DMR symbol, or it's about the FAPI interface traffic, or for the ISAC, if you want to just collect the IQ, even the time domain samples, if you want to collect it from the radio through modified interfaces between the DU and the radio, you can still do that. So the DApps the data lake also supports a standardized interface like E3 interface. The DApps can sit inside and use the data lake framework either over E3 in a real-time fashion or through a stored fashion. So that way the data becomes available from any vendor's stack in an open and standardized interface approach. So the E3
Last
is
2
used
minutes,
more.
please.
Yep.
Last 2 minutes, please.
Okay. So the next level is the open AI models. So today we are all talking about closed models where it's all, even if it is a frontier models, the telecom requires a lot more fine tuning and specialization. So those things are, I'll go to the next one where NVIDIA has released an Nemotron large telco model, the LTM, which is the 30 billion parameter model, which has been fine-tuned using 3GPP standards, synthetic logs, and fault reports. And it is specialized for fault isolation, remediation, planning, and change validation. This allows one to move from autonomy, just from autonomous network intent to complete autonomy with open models. So, and there are agentic AI blueprints, and this whole framework allows operators to secure the data and provide a sovereign infrastructure because the open weight model. So you can fine tune it yourself, run it in your own premises without having to export the data. Right? The fourth pillar is the agentic research to find the best algorithm, or the open engineer. So there is a telco engineer framework that has been released in Siona releases recently. So this allows the agentic orchestrator to launch multiple agents, and each agent can try to find a solution for your problem. For example, you take a channel estimation and give this problem to each of the agentic framework, and there can be 10 to 15 agents running in parallel, generating different solutions. So you select the best out of those solutions and then go to a second pass, right, which is called the second generation. So you keep refining the algorithms generated using specific KPIs and specific measurements and guardrails, which you put in the orchestrator, which basically selects the best solution at each pass and passes it to the next iteration. So what we have been able to achieve is improve a channel estimation algorithm, which is not an AI generated model. It's not an AML model. It's a traditional LS kind of a channel estimation algorithm. Code was supplied to the agentic AI. So it picks up the various information from different standards and other things. It understands the problem requirement and then tries to modify the code for improving the performance. So with just 8 hours of agentic AI execution, so the performance could be improved significantly over traditional LS versus, and it is going on par and better than LS MMSE type of techniques. And the code generated is open and it can be it is generalized for different channel models and the different use case scenarios. It is not very specific or tied to a particular model. And the last level of innovation framework is called the open developer, where it's not just about algorithm or inventing a new algorithm or modifying an existing algorithm. It's about generating the whole entire software. So you use an agentic framework where an agent can generate a code and another agent can test the code, and there are agents which will do the benchmarking of the generated code, create KPIs, and collect the profiles and collect the profiling data from the end user system, and then give a result in terms of whether it is suitable for the application and whether it meets all the requirements with respect to compute efficiency as well as the performance efficiency. So with this kind of a method, you are basically moving away from manual code writing method to an orchestrated code developer method, wherein the developer becomes more of an orchestrator who's orchestrating the requirements to with a set of agents and increase the velocity of code development by 10x. So the job of developer is moving away from just writing code and writing test vectors and writing test benches and then validating to designing what is the environment in which I want the code to run, what is the evaluation criteria, how do I set the boundaries, and how do I test it, what scenarios I need to meet with the generated code, and how do I collect the logs and traces and how to repeat the same scenarios. So the developer is focused more on the value addition rather than just simply sitting and doing typing the code and validating it using writing their own test cases and so on. So this is the overall innovation framework we are talking about in terms of improving the pace at which the overall system development can be done. And this whole harness and development framework is not tied to any specific network architecture. So whether it is Wi-Fi or RAN or for NTN, it doesn't matter. So this whole software development process is open and completely expandable and gives a speed of light execution for any vendor to develop the systems at large scales at very high pace. Thank you. Sorry for extending my time. Over to you, Mohish.
Thank you very much. Thank you very much, Charles Santosham. It was a very insightful session. And definitely it has triggered us to rethink about the openness. And also
You got muted, Mahesh. Mahesh, you are muted.
Mohish?
hello, hello. Am I audible?
Yep.
Yeah.
Now you.
Yeah, sorry. Yeah, you have also covered open innovation framework layers basically are the pillars what you are referring to as open source to code base, open data lake, open AI framework, and openness is actually equal to evolve and create. It is not just evolve. You have to recreate it. And also you have covered about rethink openness, basically move beyond interfaces and prioritize innovation over capability. True openness enables systems to evolve, adapt, and co-develop, not just integrate. Thank you very much. Uh, Now it has time to move on to the panel discussion. I think we are 5 minutes delay. Sorry for that. Over to you, Debashish. Floor is yours.
Thanks, Mahesh. I think we had a very good discussion till now. These presentations that we saw has actually spruced up and possibly prepared and prepped the audience. So, without much ado, let's dive straight into this conversation. Try to keep it engaging. So, I think the future of connectivity will definitely not be defined by just one technology, right? But by how effectively we see different technologies, different networks work together, integrate, and then communicate. Mobile cellular, as we see, offers definitely scale and mobility. Wi-Fi adds capacity and indoor reach, while NTN, non-terrestrial networks, can extend coverage and strengthen resilience. The opportunity right now in front of us is to create a seamless experience across these networks, supported by common standards, open interfaces, secure authentication, and viable commercial models. So today, in our discussion, we will explore what is needed to make this vision practical, scalable, and interoperable, and what roles industry policymakers and technology providers must play. So, as you can see, we have distinguished panel members. We have Abhijit Chaudhary from Neural Networks, Ashish Bose from Nokia, he has already spoken, Chandra from Fireware Foundation, already spoken, Charles from NVIDIA, already spoken, and we have Prasad from Keysight. So, let me start by asking icebreaker. This session is about open and interoperable hybrid networks. So I would like to start this conversation by asking, what does open interoperable hybrid network mean in practical terms? Is it open interfaces? Is it open APIs? I spoke a lot about APIs. Is it open orchestration in the network or open ecosystems? I would request either any one of you to start, whether it is Ashish from Nokia, Charles from NVIDIA, or Abhijit from Needle. Any one of you can shoot.
Um, so you're asking like where should the interoperability happen, right?
Yeah, I mean, when we say so, what does it means in practical terms? Is it open interfaces, open APIs? Where exactly are we? Is the openness that we are
It
looking
should
at?
be all four, according to me. It should be interfaces, APIs, the orchestration layer, the ecosystem. Everything should be open, and the underlying thing, like basically, the openness needs to be built at every different level, not just the exposure layer. That's what my thought would be.
Thanks, Ashish. Do we have any
Yeah,
supporting or counter comments from Charles or Abhijit?
yeah.
Yep.
I think adding to what Ashish mentioned, I think the openness has to go to the use case and application level too. Like, for example, let's say the device, mobile, we support Wi-Fi as well as 5G, but it may not support NTN. So, and the device authentication, right? Like we have different kind of authentication mechanisms. So when you talk about openness and we talk about hybrid networks, the devices should be able to support all kinds of network ecosystem. You should be able to authenticate with all kinds of network ecosystem, and when there is a handover it has to be seamless. So we need to have an anchor point which will ensure that the transport level protocol, not the L2 level but the I transport TCP SCTP level protocol should be able to continue, the session should continue even when we move from one network to another. So openness has to go to that level too. I mean, we talk about API orchestration, but I think we have to go much deeper and ensure that the end-to-end application should not see a glitch, should not see it should work seamlessly. That's
What you're alluding to, Abhijit, is actually just seamless integration without any handoff glitches, right?
and also authentication of that, so that and to ensure
I'll
that
I'll come to that.
single authentication should cover all kinds of networks.
Correct, Charles.
Yeah, in my view, I think open interfaces and open APIs are there in bits and pieces in various forms. I think the near-term requirement is to make sure that the open orchestration is becoming more and more prevalent, and with the use of AI, because there are a lot of variables that you need to control. So without intelligence, just creating an open orchestration, a rule-based orchestration may not work. I think, but open ecosystem to me is a little far away, I would say. So right now, orchestration is the near-term requirement with the aid of intelligence.
Great, thanks, Charles. So, where do we land with interoperability then? If we get into slightly deeper into the network, where should interoperability actually happen? At the device level, is it at the radio level, which is the access network, core network, edge platform, or through the northbound APIs, which are exposed to the applications? I spoke about that. Ashish, any comments on this? Where should the
Uh,
interoperability actually happen?
the interoperability, okay, so I would say integrate deeper and expose, I mean, or abstract at the higher level. So it's basically the core should be the converging point of all the different interoperability and legacy. Even though the lower levels, like rightfully what Charles was trying to explain, the interoperability of the data sets, like how that DU data is getting exposed, and all those things, interoperability needs to be there. And at the and at the top level, you can actually abstract and you can create vendor specific, or you can create silos on top of it.
Perfect. So I hear you, and I hope uh, our audience can also get the message. What we are trying to say here is that the interoperability and the openness cannot be looked as into silos in the different parts of the network. It has to be looked in a very holistic manner, integrated well for to get the final output and outcome as a seamless integrated approach. So yes, we get that. So but if we have to go there and achieve that, what should be tested before? Because we are talking about, the topic is about how do we integrate cellular and Wi-Fi and NTN. These come from different foundations. So if I can come to Prasad and Chandra, and get your opinion on this. What should be tested before we can claim that a cellular Wi-Fi NTN network is truly interoperable? Do we need a kind of a certification or a test bed framework for this?
Um, should I go first or?
Please go ahead.
Yeah. All right. So yeah. So the important thing is I'm not a very big expert of the networking level, and definitely there should be an interoperable testing. But I would like to highlight that there should be two-tier interoperability testing, and we should agree on the framework. So one is basically the tier one, which actually is the radio at the transportation interoperability, which Keysight and others are well placed to define actually here. But the T2 application data layer the interoperability. Again, the context data flow seamlessly and semantically consistent across three access technologies, right? So it's like if you don't have an interoperability, we all sitting together in one single boardroom or a meeting room, and when we are talking in our own languages, everything mic is working perfectly, but no one is able to understand each other. Everyone is able to hear something, but not able to understand. And this is where actually we need to have a network layer, a radio layer, interoperability, but at the same level, we also need to have a semantic and at the data layer level interoperability on this direction. So there should be a two-tier approach on this.
Got it. Thanks, Chandra. Prasad, from an
Yes,
inside perspective, you guys are big into, TNM. So, what do you have to say on this?
yes. I think it's a you have to have that interop between, because these three technologies are totally different compared to each other, and we need interop testing for physical layer because of the satellite delay Doppler channel emulation for each of these technologies are different. The second part is the protocol of the handover because each technology has a asymmetric access types. The third would be QoS continuity, the SLAs, and the last and the important part is the security continuity during the transitions, right, from cellular to Wi-Fi or NTN or vice versa. What is happening today is that the certifications are totally different for each of these technologies. It could be GCF, PTCRB, or Wi-Fi Alliance. And they are done in silos. There is no seamlessness between each of these technology. And we need a neutral plugfest driven certification test bed framework typically for across domain interoperability. So that needs to be a neutral plugfest driven certification needs to be found and validated so that there could be a seamless transition between these three technologies.
Sure. Prasad, your voice was patchy. I'm not sure if it was just at my end, but I think I got the message loud and clear that what you are advocating for some kind of testing. But if I can ask you a follow up, Prasad, has your organization done any kind of such testing for a typical heterogeneous network in the past in any country?
We have done it for NTN and cellular. There are a lot of plugfests that have been done globally with different organizations, with different regular bodies globally, and we know that there are a lot of challenges when we are doing these interoperability done between these complex networks. But there needs to be a neutral framework that needs to be defined to to transition from different technologies.
Fair point. Um, uh, Chandra, if I can get your views on the standards, because I hope you can add something on this. That is there a set of minimum standards that we need to make these kind of hybrid networks work, especially when it comes to interoperability in practice, just not in principle.
Yeah, so I think at the data layer level, so and I will split also a data layer into multiple layers. That is, the interoperability between first of all, we need to understand how are we talking. So with an API or whatever it is. So we all agree. Let's say we all agree that REST API is the standard on this. Then how are we actually going to I can actually still send the data to you with the REST API, but how are you gonna interpret that? The example which I took in my keynote speech is that I will send you 32, but how are we going to actually, how are you going to understand that? Is it a temperature? Is it a pressure? Is it something else? So I need to add this context to it, and the context of this data, when it is arranged in a particular way, then it needs to be a model. So there should be a reference data model to it, where the data which you receive automatically then can refer to a particular data model, which I am saying that this refers to this data model which is at the public space. Then you can interpret the data in that one. So there are many levels on it. First of all, the protocol layer, that what type of interface which I'm trying to use. The second is the what type of data models, so that I can actually, it is machine to machine interpretable and sendable. So I think these two are very critical when it comes to it. But then there is also one more aspect which I would like to add, and which I didn't discuss much on this, is the trust aspect. So how basically I can trust that I can share my health data to you, and how you can show that you can be trusted to me. And this trust, the way we are actually exchanging the trust is something that which we need to have an interoperability between our trust frameworks, right? Like we have Aadhaar card, we have EIDs in Europe and other. So how are we going to exchange this data? And this is going to be a massive challenge at the global scale.
Chandra, thank you so much for bringing that trust angle, because even we at GSMA, we are a global industry body. Digital trust is at the center stage of everything that we are doing when we work with not just the MNOs but the large part of the ecosystem. It has become so essential, the trust factor which you just mentioned, because till the time, and the it cannot be stressed more. I mean, you cannot uh, you cannot talk any. I mean, there is no conversation which I see these days happening in any forum in which digital trust doesn't come in. So I'm not surprised you brought in the trust angle here. So thanks for that. But Prasad, I need to come back to you again on a follow up of this, that when you but when we are looking at interoperability of such kind of heterogeneous networks, uh, where do you think is the biggest gap today? Is it the technology itself, the standards, the ownership? When we talk about the operational ownership, who executes the integration, or are there any other of course there will be business incentives as well, but what would you highlight, Prasad?
You know,
We are struggling to hear you.
hello,
Yes, go ahead.
am I audible?
You are patchy.
Three, there are three core challenges. One is the authentication and the session continuity, and we need a different, because we have been talking about trust, right? So the identity and security framework is an important aspect of having this. S- Hello, am I
Yeah,
audible?
yeah, go ahead. We can hear you.
Yeah. Okay. Yeah, so authentication and session continuity is something which is very important when we are looking at this seamless handoff. Then the QoS policy translation is something which we have to look at,
Okay.
which is very actually important between the handovers that are happening. So these are the three core challenges that we could look at between the networks.
Sorry. Yeah. Okay. Got it. Ashish, I'll come back to you with my next question. That who do you think should decide? When traffic moves between these networks. Cellular, Wi-Fi, and NTN. Is it the device, the network, the enterprise application, or and I'm opening up a new conversation, or should it be an AI driven orchestration layer? And if it is AI, can AI actually become the decision engine for the hybrid network orchestration? Ashish?
Yeah. So, in my view, no single party should decide. For today, like the devices, they actually decide a lot of these things, right? Like so, but in my opinion, it should be very clear. There needs to be a proper intent at the top, an intelligence in the middle, and the execution should be at the edges. And all these three things, like we can actually consolidate into the networks, and that is what, like, I believe Santosh and his team is doing with the aerial project and things like that. So you can take the intent, do the intelligence, and do the execution at the edges. And this part, like obviously we need to actually shift away a little bit away from the UEs or the devices making the decision at this point.
Okay, so so I was thinking of asking, the technical barriers, that is preventing the truly seamless handoff. But I'll park that question for the time being, and probably I'll come back to Abhijit, you, that do you even see that there is a need? Because you guys are big into private 5G networks, Abhijit, and you have done some fantastic work with. I know what you have done with railways. You can briefly talk about that, but uh, do you see there is an actual need in the market, and keep it India specific, for such kind of a heterogeneous network solution? Or, are we are just having a discussion for the sake of academics?
I think very pertinent question, and I would answer it in by talking about two use cases. One is really private 5G, like which is defined within a geography, like mining or energy plant, right? Which probably has a coverage of around 3-4 square kilometers that you want to cover. And lot of these industries look for an air gap network disconnected from public network, disconnected from public cloud, because of safety, security, ensuring that cybersecurity attacks do not happen on those networks. So in that kind of scenario, right, what we have assumed is that specifically most of them already have a Wi-Fi network indoors existing within their building, probably the IT network. But what they need private 5G or 5G is for the OT network, right? Like to how to manage all the vehicles or the dumpers which are moving within the mines, or let's say how the drone can survey the entire mining site, right? And push to talk, walkie-talkie, voice video communication, dispatcher system. Now, in this kind of use case, probably satellite may not be very relevant, but we do see that because the many more customers have already invested a lot of on Wi-Fi, especially on the IT and maybe the indoors, and they want to connect the outdoors on 5G. A interoperation between the Wi-Fi and the 5G network would be useful. And if you see, mostly if you talk about open, 5G in some ways is open. The RAN can be from X vendor, core can be from Y vendor, IMS can be from Z vendor. But when you go to the Wi-Fi, I think it is very close. Like you cannot take a controller or orchestration engine from X vendor and a Wi-Fi access point from Y vendor. It doesn't work. Only TIP Open Wi-Fi is trying to revolutionize and bring such things, but it's very close there. So having openness there would be useful, especially for the Wi-Fi and private 5G. Now coming to a larger private network, like what I call wide area private network, like maybe railways or defense, can be smart cities or like highways, right? Where you want to create a private network, but which covers the entire country or at least one city per se, right? I'll give you an example of railways itself. Some of the thing that we have observed is that railways, they look to have the connectivity across the railway track. They want to do push to talk, station to station communication, cab to station communication. Then they want surveillance. Like India has a cover system for collision detection. They want to track all those things. We using a communication system, and private 5G or 5G per se is a good solution because you can run all kinds of video, data, voice, low bandwidth, high bandwidth, multicast MDS system. Everything can be done. But the problem, what I see is that they also ask me a question which I'm talking from the customer itself. Suppose it's a long network, like maybe Indian Railways has 1.4 lakh kilometers of railway track. Suppose if the connectivity to the core goes down, how does the network adapt, right? Because you may not have core in or a UPF running in every station, right? So how do you do? I think these are the bottlenecks we have to solve. So one of the solution that we were kind of contemplating is NTN, as not only as a access but also as a backhaul, right? Like a redundant backhaul with NTN with the fiber being used as the primary, and also ensuring that you get a throughput of at least 60 Mbps even on the NTN if the primary goes down. So these are like small nuisances that I would like to, like small points that I want to cover, but that is where the NTN and 5G plays kind of an important role. I mean, of course, we can refine that to 6G, where you can also put radios on the satellites and then cover NB-IoT is another example. But yeah, so this is
But Abhijit, very briefly, have you been able to combine different kind of networks, if not networks, at least two networks to determine an output for any one of your customers? And if yes, then I have a question for you.
no, I don't think that the NTN and the cellular that I
No,
was talking about
the
railway.
Wi-Fi or mobile.
Uh, so Wi-Fi integration we have done, but like the Wi-Fi integration is in two ways, like in 5G. One is you put a 5G CP and you have Wi-Fi on the other end and then connect 5G. The other, which we have already done. The other way is like a N3 IWF, where you send a 5G nest. The 5G devices actually talk over Wi-Fi and you process it on the code. We have done that, but we don't have the 5G ecosystem ready yet. Like if you take a 5G phone and let's say you go indoor of the manufacturing plant, which is Wi-Fi based, it should work on the 5G nest over Wi-Fi. But the 5G devices mostly available in India that doesn't support it. So we have not been able to kind of do the 5G NAS way, but 5G CPA way we have already done a few use cases for robotics, etc.
Sure. Okay. Got it. So, thanks for that, Charles. Let me come back to you. I was talking about the decision-making loop. How will the decision happen? In such a typical heterogeneous network. But while I was thinking of asking that question, I also thought it's better that for the audience we deliberate a bit on what are the key parameters actually, which will decide the network selection. Is it the cost, the latency, the application itself, the coverage, reliability, security? um, what could be some of these factors, and which one will take precedence? Any
Yeah, I think considering the NTN, it's not coverage bound. I mean, there is no way to tightly control the coverage to a specific sovereign region or a country. So I think in my view, the sovereignty takes the foremost, because it's a legal requirement that you cannot operate outside a boundary, or the spectrum is allocated only within the specific geographical region. So that becomes the first and foremost criteria. Then the coverage. I mean, without having a coverage, you cannot provide a service even if you want to switch the network to something else. So these two being fulfilled, then you can always look at other criteria like latency. For example, if you want to hand over a user to an NTN, the quality of service that is required by the user may not be met by the latency that is coming with the NTN, or the kind of mobility. If a user is highly mobile, and if you want to put him onto the Wi-Fi network, he may not be able to seamlessly hand over across the network. So these things become secondary criteria, primary being the sovereignty and the coverage.
Understood. And Charles, what a fantastic segue you gave me for the next question, which anyway I had on mind. But previously also one of the speakers spoke about QoS, quality of service, and now you again touched on this. So um, briefly, can we realistically develop and deliver a common quality of service amongst these heterogeneous networks? Is it possible? If yes, what needs to be done
Okay.
so that the user experience is uniform?
Okay. I wouldn't call this a common quality of service. Rather than, I would say it's more of what is best possible quality of service given the network characteristics, right? I mean, it's not possible to give a gigabits per second, over a geo satellite NTN, for example, right? And also you cannot give a high speed mobility with a Wi-Fi network where the network coverage is patchy. The important aspect is to see, given the coverage and availability of the network, which of the network is the best suited for the quality of service requirements by the user. If the quality of service required is highly reliable, high data rate, then probably put him on the terrestrial network, which has the larger pipe. Or if it's a lot of video, kind of a high bandwidth requirement with not much of mobility, put him onto Wi-Fi network, and so on.
Got it. So,
So
Ashish, if I
it's not
can
a
get your thanks. Yeah, got it. Thanks, Charles. Ashish, if I can get your quick comment on this, who actually gets to decide this and how?
You mean like
Did,
who delivers the QoS?
yeah, to determine that the QoS is not hampered, uh, who will stand up and say that, yeah, I think, I can take care of this? How does you?
You need to have a common QoS framework. You cannot have a common QoS level across, but you can have a common QoS framework, and this framework can be can standards body needs to come up. Like they need to define this QoS framework, like what needs to integrate, and like what should be the kind of like um, um, the QoS that it needs to do in order to actually go across these levels of physics. So from the different networks as such.
So what you're alluding to is a minimum level of QoS, has to be committed, and below that, uh, it should not be acceptable, or rather, the service deteriorates beyond that level. So at least that minimum level has to be defined somehow and
Yep.
communicated so that everyone performs at least that uniform level.
Yep. Yep.
Got it. All right. So before we close this, I wanted to bring the business model and the deployment angle. And Neeral, sorry, Abhijit, you touch base on this. So let's see if you can add one or two more points on this. So uh, I asked about who will be the national buyer for this kind of a hybrid network. And although briefly you have done something with railways, not sure if you spoke about smart cities, but what's your take, Abhijit, on industrial automation, mining, ports, defense, or logistics? Do you think in India we have a market for this if the conditions are right in the next 1 or 2 years?
Um, uh, I mean, whenever it's a wide area network, like railways, it was one example which I mentioned, but also defense. I mean, if you see the defense, right, they need a secure network. Also, they need a wider network, like which probably around the border area. They also, one of the other use cases about defense is that when they go for camping, like they actually take the vehicles and they want a communication within around 5 to 10 kilometers across that vehicle where they do the camping, right? So it's creating a network within that area and then be able to connect to satellite to connect to the headquarters, right? So I do see that defense, railways, wider area like the shipping before the ship comes to the port, right? So that communication, port to ship communication, and these are the places where NTN plus 5G, sorry, cellular, or for example, already NTN is being used for shipping and of course for airports, airlines also it is being used. But the hybrid network, wherever is NTN is being already used, plus I think ports, defense is one key I feel. I think railways also will be a key factor. Similarly, maybe police network, like FastNet, etc. So there we can talk about this kind of hybrid networks. I do see that there is a business
Sure.
model.
Thanks, Abhijit. I'm conscious of time, and I before Mahesh, bangs the gavel, I want to be, um, looking at the time, and I think we have just last couple of minutes left before we address the Q&A. So my closing question, and this is for all. Um, Feel free to chime in. So if we have to, build a national pilot for this kind of a heterogeneous network, what, as per you, will be the easiest use case to begin with? And how do you think we can do this? What should success look like? We can
Maybe I can answer this. So
please, Chandra.
I would go back to 3 points. What is definitely, I'm sure the physical layer will be more or less interoperable because we have a precedence for that around the world before in the 6G network, and I think that is well established model. The second aspect is that we are able to communicate seamlessly without having, I don't have to make a call to you and say that, hey, what, you're sending me some data, sure, great, but what is this mean? So I think that would be the second aspect, that we don't have to do it. We are sending data in a agreed standardized way with the agreed data model, so that everyone can, whoever is sending the data, can be interpreted across easily with the machine readable format. The third aspect I would actually put back to you, Debashish, and I think this is very favorite topic to you also, is the trust. So we should be able to establish the trust between us, because I should be, so if I'm able to exchange my medical data with you, that I should be able to have enough trust that I am actually in exchanging a data with you as a medical professional, and you are relevant for me, that I can share this data. And at the same time, you as a medical professional should be able to trust my data. That is, okay, this is the valid data where I'm getting it. So I would put this as a successful factor, that when we are able to exchange the data across multiple platforms between multiple networks, seamlessly without having any issues like this.
Thanks, Chandra.
I would like to add one point here. The use case, I think railways can be a very good use case to have this national level kind of heterogeneous network. I think so. Of course, we don't have a LEO satellite, but starting with GEO, too, we can start that.
Yeah, they have plans to come big on that. They just don't want to be partners with uh, Starlink.
Yeah, I think in my view, it's more
Yeah.
like emergency response systems where it's
one, I would like to, the national level.
Prasad, Charles was responding already. Maybe I'll, we'll get to you after Charles is done.
Sorry. Yeah. Sorry. Please go ahead.
Yeah, so in my view, I think the emergency response system in India would require such a facility where the interoperable networks allows them to be continuously in connection with the doctors and the central hospitals, and depending on the area that they need to serve. For example, in the disaster areas where the terrestrial network is completely out of service, we should be able to rely on NTN or a local Wi-Fi network, which you bring up. I think that's one of the potential areas where this can be of impactful and social relevance.
Perfect. Prasad, before you give your response, I'll request our panelists to just have a look at the chat window. Akanksha mentioned that there are a couple of questions. Just see who would want to address that question. Prasad, go ahead, please.
Yeah. So according to me, the national level, the policy pilot would be where rural broadband could be something could be looked at. Where NR fails, then the fallback is on NTN, followed by Wi-Fi offload. And the success could be like the continuity in a voice call or a data call with a handover outage of, let's say, 1 second. And it gives us a QoS parity across multiple routes. So that could be something which we can look at as a success for a national level pilot project, pilot project.
Thanks, Prasad. Ashish, looks like you will get the last word on this.
Oh, okay. I was responding to the chat as such, like so. But anyways, yeah, I completely adhere to what Abhijit was saying, and what his company is rightfully doing, like so. The kind of the railway corridor is the best approach, what we should be targeting, and obviously that is something like what we can, forget about, not just about Starlink, but maybe like we can actually think about another operator who really can help us with that particular NTN part of things.
Thanks, Ashish. Did we get a chance to look at the questions in the Q&A box?
I think both questions are related to Charles' session.
Okay. Charles, you want to go ahead and give brief answers? Mahesh, how are we doing on time?
Actually, we are delayed. Last 1 minute to conclude.
Last 1 minute, Charles, please see if you can answer the question, and then we will close.
I couldn't find the questions section. Can you read it out, Mahesh? Sorry.
Mahesh, can you
Yeah,
please-
let me read it out. I
Yeah,
think this
sure.
question is from Lokesh Erickson. Please elaborate on All Star and Deep Code, the automated paper to code. What do you mean by All Star? ALLS, caps, and TAR in small. All Star.
Okay,
And
so
Deep Code. Yeah.
Yeah, so the paper to code is one of the experiments that we have done in the past, where you take a research literature document and taking the cues from the document, you generate the code for a specific algorithm or a specific implementation of what the paper is talking about. So it's about generating code directly from published paper, which can be done without having to manually code that, understand the complete paper and do the coding. So that's all about it.
Thanks,
Perfect.
Charles. The
Thanks,
next
Charles.
question is from Smita. Have you used multiple agents running convolution algorithm for channel estimation instead of MMSE?
No, I think the agents come in handy for developing code, not for doing inferencing or to do the actual channel estimation, right? So it's all about using agents to generate the code which will do the channel estimation job better for you, or take the existing channel estimation algorithm and modify it to suit the requirements of the channels. So it's not about the agent doing the channel estimation itself. I mean, if I understood the correct question correctly.
Thanks, Charles. Over to you, Debashish, to conclude.
Well, I only have thank you and gratitude to all the speakers for sharing their deep insights. Taking out time from their busy schedule and sharing their knowledge with the audience. Thank you so much, Chandra, Ashish, Prasad, Abhijit, Charles. Um, Thank you very much, and back to you, Mahesh.
Thanks, Devashish, and all the panelists. It was a wonderful panel discussion. Before concluding the panel discussion, I would like to introduce Prasad Petkar from Keysight Technologies. Actually, the other four panelists, we will introduce them as part of the keynote session, whereas Prasad Petkar, since he was not part of the keynote session, we would like to introduce him. Prasad Petkar, a seasoned telecommunications expert with over 20 years of experience in device testing, base station testing, and network optimization. He currently serves as the communication solutions architect at Keysight Technologies India, where he leads pre-sales for advanced wireless solutions. Prasad also holds multiple US patents and holds a master's degree in data science from BITS Pilani, bringing together deep technical expertise and analytical insight. Thank you very much, Prasad. And
Thank you.
thanks, Debashish, for a wonderful panel discussion. And we would like to conclude panel discussion. And Akansha, shall we move on to the next item? I think the next item is
Yes, sir. It's the
concluding
concluding
remarks
remarks.
and vote of thanks. Over to you, Abhijit. Floor is yours.
Yeah, thanks, Mahesh. I think it has been a very wonderful session listening to fellow colleagues, and some of them I know very well, like Devashish, Mahesh, all of you. Thank you so much. To start with, Devashish, I mean, it was great to know and understand the open API framework that you talked about, and how in Sri Lanka they are able to detect scam and solve that issue. I think that was enlightening for me especially. And good to know from Chandra about how vendor lock-in can be taken care of using open data modules, like the model context protocol. And you talked about IUDX using your solution. I mean, in some ways I'm connected to IUDX, so really glad to know about that. I know Inder very well. And coming to Ashish, as you mentioned, agentic systems are trying, will revolutionize the telecom ecosystem, right? Totally agree to that, and looking forward to the revolution which will come here. Uh, Thank you, Charles. I think you talked about the importance of open source. It's not only about open APIs, right? It's also about open source and open data lake, and ultimately agents coding, testing, and also evolving the system. It was really great to know about that. I mean, while we get so much into like our day-to-day life, it's great to unlearn and learn from all of you here. Prasad, good to know about all the plug, plugfest which has been you are conducting, and on the NTN plus 5G side. I think there is a lot of things to learn from that, and probably we can discuss more on that later. So thank you so much. And along with them, of course, my like session coordinator Mahesh. I mean, you have taken a lot of work to get the speakers onboarded. It was really great working with you on this session 6. And lastly, and but not the least, Mr. A.K. Mittalji, it is glad to work with you, you being the session convener, and then Akansha to coordinate all the meetings that we had. I know on the backstage, a lot of effort has been put from the TSDSI team, and hopefully the session was really useful to all of you as panel members, and also the people who, the audiences who joined. Hopefully it was a great learning experience for all of you, and let's learn together and spread the word. Thank you so much. Akansa, over to you.
Thank you. Thank you, Abhijit sir. Thank you to all the speakers and coaches for giving us your time. Before we conclude, we kindly request all the participants to share their valuable feedback on today's session. Your feedback is extremely important to us and will help us further enhance future editions of TTDD conference. You may submit your feedback by clicking on the link shared. It will be shared in the chat window, or by simply scanning the QR code I will share in a minute. And thank you once again. We warmly invite you to join us tomorrow for TTDD 2026 concluding day, which will be held in hybrid mode at Hyatt Regency, New Delhi. And the session flow for tomorrow is this. So thank you, everyone. We can close the session now.
Thank you.
Thank
The
you.
session is closed. Thank you very much.
Thank you.
Thank
Bye-bye.
you.
Thank you so much.
Thank you very much. Bye-bye.